Hello, this is a tutorial about the operating system OmniOS Community Edition, omnios.org. This is an operating system that's a continuator of the Open Solaris operating system. There's more continuators of the Open Solaris operating system. This is one of them. It has a recent release, May 6th. The release has this version 151050. It contains the usual features of Open Solaris, so ZFS for storage, zones for lightweight virtualization, has additionally Beehive and KVM for hardware virtualization for virtual machines, networking with Crossbow, dtrace, and IPS, the binary package manager. It's using illumOS. illumOS is a continuation of the Open Solaris ON. OS/net. So the latest publicly open source version available of Open Solaris has been forked as illumOS. This is the source code Git repository under github.com/illumos/illumos-git. It consists of a single directory, the directory /usr/src. In here we have the kernel mode and the a minimal user mode similar to FreeBSD src or the base stargz. Contains bootloaders, kernel modules, kernel drivers, many packages. This is the package manager IPS, image package system. The package manager uses a repository similar to Linux operating systems. The command line is ipkg. Okay, let's look at the operating system. Let's see how it looks like. So Open Solaris you would usually install by downloading an ISO file, which was very similar to a Linux ISO installer in the sense that after you install it in a virtual machine or on hardware machine, you were greeted by a graphical user interface, which was based on GNOME 2. Okay. illumOS recommends that you install the operating system OmniOS, which is a distribution of illumOS, which adds many additional packages on top of this Git repository, using the technologies that are defined inside of illumOS, such as IPS, the ipkg command line, ZFS, dtrace, Crossbow, zones, boot environments, etc. And this is what we're installing right now with the operating system OmniOS Community Edition. I have already installed it. This is the way it looks like. It says that it's a minimalist. It's a server operating system with just the features that you need, which means that it contains 2 IPS package management repositories, which do not contain any graphical user interface applications or the X server. The two package management repositories are this one, the core, and the extra. Let's navigate to these URLs where the package manager repository is being served. In here we can browse the entire list of packages. The operating system version OmniOS Community Edition is 151050. We go browse, and this is how an IPS repository web interface looks like. You can install IPS packages either by specifying the short package name, such as ACPI in this case, or the long package name, one with slashes, so developer/ACPI. So in the first Git repository, in core, we have many drivers packaged as IPS packages, the ones with the long package name starting with driver/. Okay, internationalization translations, the locale slash, networking tools such as Telnet, package management tool, PKG, printing server, Perl and Python programming languages, services, this is Beehive, this is the package similar to QEMU KVM, so a hardware virtualization software, probably comes from FreeBSD. There's the bootloader grub, command line support, term info, keyboard, console fonts. So it contains text user interface. You can connect to the operating system using the OpenSSH server. The OpenSSH server is available by default, but not enabled by default. So when you install the OmniOS CE operating system, the installer wizard is in text user interface mode, and it will ask you if you want to enable the OpenSSH server, and it's a good idea to enable it. Okay. ZFS, Samba, network file system. So many low-level C libraries that you would expect. A C library, iconv, crypto libraries, a DHCP client, zones. There are branded zones available. The one that's interesting is ipkg src. So this is the port tree from the operating system NetBSD, is highly portable, available to many operating systems such as Linux, and it's also available for many IllumOS based operating systems. This is the LX branded zone for Linux compatibility. Let's look at the other repository, the extra. Okay. This extra repository, the packages start, the full name of the packages starts with OOC/. I see command line tools, Midnight Commander, the mail client MUT, web server software, PHP, automation, background, audio codecs, FLAC, databases MariaDB and PostgreSQL, additional C compilers. So the IllumOS operating system is trying to switch the source code from needing Sun Studio C and C++ compiler to using the GNU C compiler, GNU compiler collection. And also using additional GNU tools from the GNU toolset, such as GNU Make, AutoMake, AutoConf, etc. So IllumOS is trying to replace some of the components it inherited from Open Solaris ON with source code packages that are well maintained, such as the GCC compiler. And in here, in the extra IPS packages repository, we also have additional compilers such as CLang with many versions, CMake, Pascal, the GNU debugger, Go programming language, Ninja, Make replacement, Rust, Subversion, version control, file system in user space, Emacs, text editor, more text editors, QEMU, such that you can run the QEMU virtualization software inside of an OmniOS installation. For instance, if you have installed OmniOS on a hardware computer. Liberation fonts, support for HTTPD Apache, and for SVN, APR util, font tools, ELF support, compression libraries, more fonts, DNS mask, Open VPN, Open LDAP, so many common network servers that you would use on a server operating system. Tailscale, WireGuard, the CAPS print server, Node.js, Ruby, TCL, so additional programming languages, and then the HTTP server Apache 24.2.4. Another HTTP server, Nginx, antivirus software, support for the Windows anti-file system in user space using Fuse. Top, terminal multiplexer, QEMU IMG tool, U-boot for ARM, and then VirtualBox and additions. So additions would be you install it if you're running OmniOS inside of a virtual machine. And X libraries. Okay, so no X11 server, no Xorg. And then there's a third-party package manager repository. The third IPS package repository is this one, sfe.opencsw.org. Let's look at the list of packages. Software packages for Solaris, not for Open Solaris, but for Solaris, for other operating systems based on IllumOS, such as OmniOS. SFE is probably correlated with TomWW, with package build on SourceForge, which is a repository that contains RPM style spec files, out of which IPS packages are being built. SFE stands for spec files extra. Let's look at the available packages. So compression algorithms, audio video codecs, more servers, audio, more GNU tools, the GNU GUIL programming language, Perl 5 with many packages, Python, GPGME, mail servers, more GCC versions, Vala programming language compiler. Samba Windows Share Server, SMTP mail server, Tmax terminal multiplexer, and Nginx. So again, no graphical user interface packages. So if you take a normal Linux operating system, you remove all of the Xorg, Wayland graphical user interface packages, then you have a subset of the remaining packages available in the 3 IPS package repositories that are available for OmniOS CE. All of the rest of the software you install in a Solaris branded zone for package SRC, not for package build. So package build is the Open CSWSFE IPS package repository, but package SRC, the ports tree from the NetBSD operating system. Let's look a bit at the actual operating system. I'm connected to a virtual machine that's running OmniOS using the SSH protocol. Uname -a works, says SunOS, which is a keyword related to Solaris and OpenSolaris. df works. I'm using the default options provided by the OmniOS installer, which is to use ZFS. Mount shows the currently mounted partitions, ZFS, zones, pool, home, etc. No free. Okay, so it's a classical, normal Unix-like operating system with a C library, with a normal command line Unix user space. Paginator more. The bash shell is available straight from the operating system installer. Similar to a Linux operating system or a BSD operating system. Let's download and install OmniOS from scratch. So we're on the home page of OmniOS, omnios.org. We go in the top of the web page, the tab Downloads. The current release is new from May this year. We have the options of an ISO file. I have already downloaded this file. Let's create a virt manager virtual machine. File, new, virtual machine. Let's select the ISO. It's this one, OmniOS -r the version.iso, 290 megabytes. Virt Manager doesn't find a template suitable for this ISO file. Let's name this OmniOS. Customize. So it does know the newest chipset, does know BIOS. Does know 10 gigabytes of RAM. Not all operating systems support such a thing. And the hard disk, the fastest hard disk that's supported is SATA. There exists a package for virt.io, but maybe it's not installed by default. So make sure you're not using virt.io for the virtual hard disk. SATA is okay. It does, the operating system OmniOS does support SATA CD-ROMs. Network interface card, I'm going to go with Intel 1000. We're probably not going to get at the graphical user interface, so we can keep a tablet in here. Creates the virtual machine, virtual hard disk. This is the boot screen. In 10 seconds we'll boot on the first option, which is multi-user, or you can press enter if you don't want to wait. It will start the OmniOS installer by default when it boots in live CD mode from the ISO. This is the installer text user interface wizard. English US enter. Find disks, create ZFS pull install OmniOS. Okay. I want to select the available hard disk using the space key on my keyboard, then press enter for the OK button. It uses ZFS, compression, and not MBR partition scheme, but GPT partition table. Okay. Operating system name OmniOS. Okay. We need the time zone. Page down. A ton. United States, the first option in there, Eastern. Okay. It's creating the ZFS partition scheme. Okay, and we're almost done. The ISO is really small, 300 megabytes. It probably just copies over the content of the pre-installed operating system that has been copied to the ISO. Okay, it creates a boot environment, a BE. You can configure initial system settings and reboot. Okay, we want to do additional configurations. We want networking. We don't want static, we want DHCP. Okay, so we now have DHCP. It has found the network interface card Intel 1000. Return. We want a local user count. I've pressed the tab key. Press enter. I can select bash, which is a good thing. So this is for pfexec, grant primary administrator role. And I'm also installing sudo support for the user administrator. So I'm pressing the down arrow key and then space key and enter. User administrator was created, that's great. We might want to set a password for the user root. Yeah, we want to. Okay. SSH server, yes, please, always. Cloud init. Extra packages repo, so that's the two IPS package repositories are both enabled, both the core and the extra. And that's about it. Return to the main menu and reboot. Let's look at the documentation on the OmniOS webpage. On the top of the page, top left, documentation. We can see how to install, installation walkthrough. We're using x86-64. We've used 10 gigabytes of RAM, 200 gigabytes of virtual hard disk. This is the text user interface installer wizard. We have done all of these steps. And now it's going to reboot into the installed operating system. Let's make sure that the ISO has been removed from the CD-ROM drive. It has. In boot options, there should not be enabled SATA CD-ROM 1, just the hard disk, which it is. So we can be sure that Virt Manager QEMU has booted into the virtual hard disk, not into the ISO in live CD mode. Okay. In here we have created a user. We can log in with that user, or we could just ignore the virtualization software Virt Manager console altogether, get from the virtual machine information, the network interface card's IPv4 address, and connect using the SSH protocol. And we're logged in. Let's now prove that sudo works. Okay, let's see what are the next steps. Says getting started guide for the next steps. So we could use pfexec or we could use sudo. I'm going to use sudo. ipkg is the binary package manager from Open Solaris. So refresh, downloads package metadata, package install installs one package, package uninstall uninstalls. Package update does the similar of apt upgrade, so it installs newer version for all of the packages that are installed on the system. There's list and info and search. So a command line very similar to the apt command line, for instance, the apt package manager command line in Ubuntu or Debian family of Linux operating systems, with this exception that update is named in here refresh, and upgrade is named update. But search exists. Okay. Mediator is similar to apt alternatives, update alternatives. Okay, so let's do what it says in here. So package refresh, let's download the latest metadata, which is the list of available packages in the two package repositories that are enabled by default if you install OmniOS. I'm not going to enable the SFE package repository for OmniOS, and we're going to look a bit at the minimalist principle of OmniOS, which is called KYSTY. Keep your stuff to yourself, which says that it's preferable if you keep the OmniOS global zone only using packages installed using ipkg from the two official OmniOS package repositories, so core and extra. So that's the only thing that you put, for instance, into /usr. And if you want additional things, that's not a problem. And you can use zones to install additional software. So you should use a layer cake approach to the packaging system. Let's try to continue with the tutorial, and then we'll try to install ipkg src in a branded zone especially for ipkg src. Let's see how far we get. Okay, so we did package refresh. Package list -u shows the list of packages that are installed on the computer. The list of packages is really short. OpenSSL, kernel, sun WCS, exe for compression. Let's upgrade all of the packages, ipkg update. There are packages that can be upgraded, sun WCS, and curses, so 9 packages in total, OpenSSL 3. Vault management, kernel, kernel platform, and it's requiring a reboot because it has upgraded the kernel. Says that a new boot environment has been created with this name. A reboot is required. And we can reboot the Open Solaris way either using shutdown -i6 or init 6. shutdown -i6 will wait a minute and broadcast the shutdown messages. Let's go with init 6. Let's look at what it's doing. So it's restarting immediately the operating system. It's booting from the hard disk. You have option 6 to select the boot environment, for instance, to boot in the previous boot environment. The operating system has finished starting, so we can reconnect if we know how to do that. Yes, we know. Okay, let's become super user again. Make sure you're not rebooting with anything else than init 6 or shutdown -i6. Don't use shutdown -h, shutdown -p, or reboot or something else. Okay. Package list -u lists the packages that are installed on the computer. And package list -a searches for substrings or globs. The question mark means any character once. Two question marks means any character once, then followed by any character once. Okay, so if you want the latest GCC, that's developer/GCC 13. Okay. OmniOS has enough packages such that you can rebuild OmniOS and IllumOS. And then from there on, using branded zones such as the LX Linux branded one or the package SRC one or the iPkg one, you can install additional software in Solaris Zones. And you also have the two virtualization softwares, which is Beehive and KVM, such that you can run any type of virtual machine, including other operating systems such as Windows, Linux, or FreeBSD. Let's install these packages, but the newest version. So that's ipkg install. You can use either the full path, the full name of the package, or the short name, such as header in this case. We're not going to build OmniOS. In the list of available package repositories, you can see that there's this concept of a release such as 151050 and bloody. Core has a release and a bloody version, and extra has a release and a bloody version. We'll also install all of these development software packages. Let's see where Midnight Commander was. We just saw it exists in here. So this is the one. In the extra is called MC. Let's actually install this too. Okay, so we need to provide the full name of the package, which is this guy. So Midnight Commander is a GNU project, is a file manager for the command line in text user interface mode, orthodox twin pane. Allows you to easily navigate through the file system, easily copy, move, rename, edit files. So what we have installed right now is according to the KYSTY principle, just the base system. It only contains the files that existed on the installer ISO file, plus some packages installed from the two official package repositories, core and extra. Okay, so the number of files on the file system is really small. The file hierarchy is what you would expect. So there's no /bin, no /sbin. We're on ZFS. There's no possibility of putting the files, the operating system, without having /usr mounted. There's this symlink /bin, which points to /usr/bin. Okay, this is /sbin. I stand corrected. This is boot environments. This is crossbow, ifconfig networking, mount partitions, the run levels, additional ZFS command lines. bin points to bin. Okay. In here, we would expect from coming from a Linux background to only have 5 directories in /usr. So bin, sbin, lib, and include, and share. But there's all sorts of additional directories in here. /proc, /perl, /net, /kvm, etc. Home directory is where you would expect, /home/administrator. /root is what you would expect. /dev. Etsy looks familiar. Run levels. Okay, it uses the default service manager from OpenSolaris, which is SMF. Okay, let's continue with the tutorial. Let's install all of these development packages. So we started off with 9 PKG packages installed. Now we probably have around 100. Let's actually look. How do we list packages? So pkg list -u only shows the packages that have newer versions available in the package repositories, and package list shows the list of installed packages. We can see that we have installed GCC 13. And application MC. So once installing OmniOS, you don't get 9 PKG packages installed, but 300 by default. So there's this binary package build essential, which will also install the correct version of GCC that's expected when building OmniOS source from scratch. So this prefers GCC 12. So the documentation for how to install the binary packages for the branded zone for package SRC, how to create the zone for package SRC, how to install either binary packages or build packages using package SRC inside of that zone is not up to date, not centralized. So I'm using bits of information from different web pages, and I'm doing a ton of guess. Maybe what the steps that I'm following right now are completely wrong. But I guess that I will need this package installed, the brand for zones package SRC. So let's install that. Alt backspace works as expected. So it downloads 2 binary packages. No boot environment was created, no need to reboot. Next up, I need to follow the documentation on zones. So zones is lightweight virtualization, similar to Linux Docker. It's not really running a hypervisor or a para-virtualization. You can have hardware virtualization inside of a zone. in order to have limitations on resources to be used. You can allocate to one zone just half of the CPU threads, for instance. And then you have Crossbow for creating virtual networks. Okay. There's the ipkg branded zone, which runs an entire copy of OmniOS, but you can install different binary packages inside. There's a concept of global zone, where we are currently located. There's some synchronization between the GZ and the branded zones. You need to be careful with the boot environments, and when you do major version upgrades, you need to detach the ipkg branded zones and then reattach them. Okay, then there's a linked ipkg, LIPKG. So the installed software inside of the zone is linked to that of the global zone. If you upgrade the package from the GZ, the packages inside LIPKG zone are going to be automatically updated. Core system packages. Okay. Sparse. File systems directly shared with a GZ, which makes sparse branded zones really, really small. You need to be sure not to install any software to /usr. If you install into /op, then that software will work correctly in a sparse zone. And then there's pkg src. And Elix for GNU Linux compatibility. For the hardware virtualizers, there's Beehive and KVM branded zones. Okay. So now we have installed hopefully the branded zone for pkg src. That's what says in the description, in the summary of the package. Let's create some zones. We are going to create a ZFS pool for zones. Okay, says that in the examples that follow, we're using a branded zone of type pkg src named test. Let's see if we can actually create it. Says I cannot switch to the test zone. No such zone exists yet, so let's create it. We're using the zone template package src and has been created successfully. We're using the ZFS pool /zones. And now we can exit zone CFG. Let's see information about it. So the storage is into /zone/test. The name is test. It's branded of type package src. Let's provide a network interface card and networking inside of the zone. We're using the auto network interface card in here from the global zone. So let's type all of these. So we're inside zone CFG shell right now. We're adding a network. So this is Crossbow plus Solaris Zones. I'm selecting and middle click paste. DNS servers. (1.1.1) IPv4 address for the DNS server. We should probably not add this DNS domain because it's using omnios.org. Okay, using Crossbow we could create a virtual NIC, network interface card. We have configured the zone and now it must be installed. Installs the appropriate software and may take a while. ZFS file system for the branded zone, named test. It's using the two package repositories, core and extra, not bloody but the release version. It's installing 186 IPS binary packages. And then it will install the ipkg src bootstrap. So ipkg, lipkg sparse, and pkg zones have boot environments which are linked to the GZ global zone boot environment. This means that we need to have a different place where to store data for this zone. Okay, so within /zone/test/data, and it's mounted inside the zone as /data. Let's actually do this. Okay, so now we have a zone where pkg-src exists, its dependencies, bootstrap, executables, etc. exist in there. The documentation that I was missing is this one. So documentation and creating a simple zone. In here it says that there are IPK packages for the various brands. And you need to install the correct package. Okay, so let's do our booting and logging in steps for the test zone. So zoneadm, the name is test, boot. Doesn't have a network interface card. I could not boot the package-src branded zone, so I have deleted it. The procedure for deleting a zone is like this. I've searched OmniOS how to remove a zone. It takes you to the Oracle documentation. Says that you should stop the zone, then uninstall the root file system, then delete the configuration, and then when you list the running zones, there should be just the global zone. By default, there's a GZ global zone named global of type brand ipkg and shared with path /. And on Solaris, it's of type of brand Solaris. And now I'm following the tutorial from OmniOS for the first zone in order to have a zone that at least boots. We already have run this thing. Not really. It's called zones in the package branded zone. In the simple zone, it's without an S. So let's do that. Okay, let's see all of the packages for the brands. So we've installed this one. And now we'll install this one, the sparse one. Okay, let's list the network interface cards. This is the one from QEMU, the Intel 1000. It says physical, MTU, and up. So the exact same output as in the tutorial. Then it says that I should run this command. Create virtual network interface card from the Intel 1000, and the name is going to be firstzone 0. We're using the sparse brand for the zone. Now we're creating the configuration with zone CFG. A network interface card inside of the zone. It's going to use the network interface card firstzone 0, which we've created here. Verify the configuration, commit, and exit the zone CFG REPL. Install the zone. So creates ZFS, file system at /zone/firstzone/root. We're at this line. Okay, so that's why they say that sparse zones are small, cheap, and fast to create, because that's how long it takes to install a zone of type sparse, the brand sparse. Okay, let's see if we can actually boot this time. Yay. So now we're connected inside of the zone. Says up for 0 minutes. Let's see if we can ping. Nope. We don't have DNS resolve, so that we have added previously for the other zone, the one for PKG SRC, with block like this one. Okay, says that we can still inside of the configure DNS. The prompt says that we're not inside of the zone in here, but we're inside of the global zone. But at least we could boot. So we'll need to create a first zone, but one that has a DNS configured. I have managed to finish this tutorial creating a simple zone. The problem was that I was using the wrong IP address for the virtual network interface card. So this is the solution. You run on the global zone, ifconfig, you find out the name of the network interface card device, and then you also need the IPv4 address of the network interface card and also the gateway. And then you use this value, and then in my case 192.168.122.1, which is the gateway. So I'm listing the zones. There's just one zone which was configured incorrectly. I'm stopping it. I'm deleting the ZFS resources. I'm deleting the zone config. Now if I list zones, there's just the global zone. Then I'm also deleting the virtual network interface card for the first zone using the command line dladm delete -v nick firstzone 0. Now I only have one link in DLAM. Then I'm creating the virtual NIC again, firstzone 0. And then I'm configuring the zone. So basically I'm following all of the steps until here. Okay, so this thing. In here I put an IPv4 address that's not used in the IPv4 range of the network interface card of the OmniOS operating system. So the network interface card of the OmniOS operating system has IPv4 address ending with 148. So I'm allocating the address ending with 150 to the virtual network interface card firstzone 0. And then this is the IPv4 address of the router. And then from the other tutorial, the tutorial on managing zones, I'm taking the zone config lines which set the DNS server correctly inside of the zone, which is this part. Okay, then you might verify and commit, which I do, and then I go exit. The zone is configured. Now we can install inside of the zone. which is I'm back to the tutorial with the first zone. So this line, I boot successfully. I log in. After you log in into the zone, you need to wait a number of seconds, maybe 1 minute, and then run ipkg show addr. So this, if you run it immediately after logging into the zone, might not show anything. So you keep running this command line until the network interface and the network configurations are shown the way you want it to be. At this moment, the file /etc/nss_switch.dns/etc/nss_switch.conf and /etc/resolve.conf are created automatically inside of the zone by the zone management tools. At which point you can ping the IPv4 address of the virtual NIC inside of the zone. You can ping the OmniOS network interface card, and you can also ping anything on the internet. In order to exit from the zone, you either run exit or Ctrl-D. Now I'm going to delete this zone completely, recreate it, but this time I'm not going to use the brand sparse, but I'm going to use the brand package src. I have deleted the zone. I have kept the LOOPBAK link. This is configured correctly, no need to actually delete it. And now I'm creating first zone again. Okay, and the brand will not be sparse, but package src. Listing -t. I messed things up. Okay, so I've exited zone CFG with exit. Asks me if I want to save this incomplete configuration. I go no. So really quit yes. And now I'm trying to create the zone again. And this time I'm specifying the template package src. Okay, maybe it's equivalent to going create without parameters and then you set the brand to src. I have created a zone identical to the instructions on creating a simple zone but with the correct IP address. And the difference is that I'm specifying as template the package src brand for the zone. Once logged into the zone, so I'm installing the zone, I'm starting the zone, logging in. I have all of these package src executables available. I have a remote already configured for binary packages built using package src from smartos.org. I have the package manager package in, and also the more low-level executables package underscore add package underscore delete. Let's see if we have binary packages from package src, or if we just need to build from scratch all of the packages using package src. So package src is a file system, a tree of directories, which contains the recipe for building various open source packages, probably using Makefile, similar to FreeBSD ports or Gentoo portage. So package in search, package in install, package in upgrade, and I have run package in update. So this fetches the package metadata, the list of available packages on the remote. Let's do a search for a random package. And the Nginx is available as a binary package. Let's look at all available packages. There's even X11 applications such as the game Frozen Bubble. Let's find one package, install it, and that should be all. Let's make sure that the text user interface application editor nano does not exist. I'm trying to do auto completion does not work, which nano doesn't say anything. I cannot start nano. So let's install it using package in. Let's search for the package using package in. Okay. So package in, search nano, and it's this package. And then let's install it. Okay, so just inside of the zone, we'll install software binary packages created using package src build meta framework. For instance, it also installs all of the binary packages which are dependencies of Nano, such as ncurses, from the same source. And everything gets installed into /opt such that it doesn't touch /usr, which is mounted read-only in the zones of brand package src. And now Nano should be available. And here it is. Okay, so we're inside of a virtual machine. In there we have OmniOS Community Edition operating system installed. In there we have created a Solaris zone branded of brand package src. And in that zone we have installed from the package src source 3 a binary package that has been built from there. And these binary packages have been built by Joyent, which is a company for their for SmartOS and other operating systems which are using IllumOS. And these packages work correctly in here in this OmniOS zone of brand package src. Thank you.